So you've seen how to do a strong acid problem at the ending of the last video. I'm going to quickly go over how to do a strong base, a weak acid, and a weak base to get you started. And those are the only ones that you should be worried about until Thursday on the back of acids and bases 1. So strong base solution is similar to a strong acid. Strong means that it completely goes to the right. So when I'm looking at a formula like this, I'm assuming that KOH is going to go completely to K plus and OH minus. Because it's strong, it will be a much easier problem for us. So what we do is we just assume, and I'm not going to write all of this on my normal problem, but the strong base, SB, it's meaning it's going all the way to the right. It's 100% dissociation. So I can assume then that 0.00125 molar of my KOH is also of my K plus and my OH minus. Well, the OH minus is the only thing that's going to matter. So that means that I have the same exact concentration for my OH minus. So now use the formulas that you have, and you can apply that to determine the other things that are required in this problem, which would be POH and pH. You already have OH minus. So that is problem number 10. Problem number 11 is a weak acid solution. This is different. This is my formula right here. As you can see, HOCl will become H plus and OCl minus. The issue is this is a weak acid. So weak acid does not allow me to know that it is 100% dissociation. In fact, it's hardly anything at all. So how far to the right will it go? The very fact that there's a Ka value actually is a big hint that it's a weak acid solution. So in the future, we won't have titles saying weak acid. When you see Ka, it will be automatically, oh, that's a weak acid. This is how I have to approach it. Remember, K tells me how far to the right or how far to the left a reaction lies. So, weeding at icebox. So we assume that we know the amount of the initial, which is 0.00125. So then what do? You know that those are zeros. Do what we do with ice boxes, apply it to my Ka, and you can determine the things that are being asked. FYI, in the problem it says use ice boxes, so that's a huge hint. But this is how you're going to figure it all out. Reminder, at the ending, because you only have 0, this is going to be x. X equals H plus. So what's that going to be? That's the beginning point when you finish your ice box. The final problem is a weak base solution, really similar to weak acid. Bases will always be one more step no matter what, you guys, because pH is based off of H, and bases have OH in them. So when I look at this equation, I have NH3, and we will discuss this a little bit more, but it has to react in water. You have to add the water to bring that oxygen in there to create an OH. Reminder, think of this as HOH, and this makes a lot more sense. Please note my states of matter. Because water is a liquid, and these other ones are AQ, when I'm dealing with my ice box, this will not count. So again, I put those as zeros, and X at the end will become OH minus. And you can move forward from there. Here's your KB. Plug it all in. It'll all work out for you. Okay? Reminder, all the answers are on the bottom. Give it a shot. Please do 9 through 12 on the back. And when you are done working in these problems, you do need to do a very short and small quiz online. Good luck.